going to begin Unit 2.6, which is planning a proof. We've given reasons in proofs, and we have done a couple of one entire proof together. But we're fixing to have problems to where the student is to be able to do an entire proof on their own. Before we do, we're going to introduce a couple of more theorems. The first one is supplements. We know supplementary angles are two angles whose measures have the sum of 180, recall, and the way we remembered that is the S turns into an 8 when you slash it, so there's the 8 for 180. But supplements of equal angles are of the same angle are equal. Supplements of equal angles or of the same angle are equal. In this diagram, we can see, because of the definition of a straight angle is 180, two angles whose external rays make a straight angle are called a linear pair. Therefore, this pair of angles that make the line 1 and 2 are not only called a linear pair, we can say that they are supplementary. So we say that angle 1 is a supplement of angle 2. Likewise, over here, it's still a straight line 180. This is still two angles whose external rays form a line, a linear pair. And so then we can say that angle 3 and 4 are a linear pair, which means that they're also supplementary. So we can say that angle 4 is a supplement of angle 3. So we have that angle 1 and 4 are supplements of angle 2 and 3. If we knew that angle 1 was equal to angle 4, then we could reach the conclusion that angle 2 was equal to angle 3, because supplements of equal angles are equal. Supplements of equal angles or of the same angle are equal. Likewise, we could say that complements of equal angles are of the same angle are equal. Knowing that this is a right angle is 90 degrees. So we can see that angle 1 and 2 are two angles whose measures add up to 90 degrees. So we can say that they are complementary. So we can say that angle 1 is a complement of angle 2. Likewise, we have another right angle. Angle 3 and 4 are two angles that add up to 90. So we can say that they're complementary. So we can say that angle 4 is a complement of angle 3. So angle 1 and 4 are complements of angle 2 and 3. Therefore, if angle 1 is equal to angle 4, then we could conclude that angle 2 is equal to angle 3, because complements of equal angles are equal. Okay? And we're going to use this in some proofs later on. Remember that everything that we turn into a rule, postulate, theorem, we can use to prove yet other rules. Now, steps in planning a proof. We're going to kind of have a little jingle for this that we'll end up saying. We're going to end up saying, write the given proof, put the statements on the left, reasons on the right, draw the diagram. Take what you're given, mark it in the diagram, write statements and reasons derived from the markings in the notes sections. Think of all the ways you can prove the prove part. Use your given and diagram to eliminate as many ways as possible and choose one way to prove it. And then line up your statements so they say what that theorem, or what a rule, a theorem for proving it says. And then we're going to check our statements and reasons from the bottom up. Now here's the jingle. It says set up the chart, but what it's going to sound like is write the given, prove, proof, put the statements on the left, reasons on the right, and draw the diagram. That's just getting set up. We're going to take what we are given, and we're going to mark it on the diagram. and write statements and reasons derived from the markings in a note section. We're going to think of all the ways, even write down all the ways to prove the prove part. We're going to use the given and the diagram to eliminate as many ways of proving it as possible and try to narrow it down to one way that we're going to prove it. So there's going to be a theorem, which will be our final reason that we're going to prove it by. So we need to line up all the statements so that they say what that theorem says. That means we have to know every theorem in the book. We have to understand it upside down and backwards, and we have to be able to visualize that theorem. Once you think you have your proof done correctly, then here's how you check it. You check the statements and reasons from the bottom up, and we'll make all of this make sense in just a moment. We hope. It takes a lot of study and a lot of thinking to get this to happen. But just hang on and we'll take you through it, and hopefully that'll make good sense. Okay, so let's just look at example one. We're going to go ahead and give you the statements here and let you do the reasons. We're going to do most of this homework together, and what we expect the student to do after watching the videos is to go back and try it on their own. In other words, get a clean sheet of paper, rewrite the proof, think through it on your own to make sure that you can do the logical reasoning. If you accept the work that's been done for you as your own work and never really studied or never really work your way through it, then it's not going to really stay with you very long. It'll just kind of be in and out. Now, it's all been kind of set up. See, here's how we would start our proof. We would say, write the given, prove, proof. Put the statements on the left, reasons on the right, draw a diagram. See, that part's already done. So write the given, proof, proof, put the statements on the left, reasons on the right, draw the diagram. That's just getting things set up. And whether we're doing the whole proof or just doing reasons, we're going to take what we're given, we're going to mark it in the diagram, and we're going to write statements and reasons derived from the markings in a note section. Now this says that ray BF, we're going to draw a picture of that here, ray BF bisects angle ABE. Now we got to go back to the definition. An angle bisector is a ray that divides an angle into two equal adjacent angles. So what we get out of that is that angle ABF is equal to angle EBF. And we can justify that with the reason definition of an angle bisector. Now, we know that before you can say definition of, you have to have the word, there's the word, and what you get out of it, and here's the what you get out of it. And so we need the word first, so we need to put in the proof before we say that those are equal, that ray BF bisects angle ABE, and the reason for that statement would be that it was given information. Okay? So here's what we've done. We wrote the given, proof, put the statements on the left, reasons on the right, drew the diagram. We took what we were given, marked it in the diagram, and wrote statements and reasons derived from the markings in the notes section. Now, if we were doing the entire proof, what we would do next is we would take what we're trying to prove and we would make it the last statement in our proof. Now, if we was doing a note section, then we'd put it down here at the bottom of our note section. And the entire proof is really about trying to make the reason we choose for proving that come true. Okay? And so here's what we would do if we were doing this proof by ourselves. We would write the given, proof, put the statements on the left and the reasons on the right, and we would draw the diagram. We would take what we were given, mark it in the diagram, and write statements and reasons derived from the markings in the notes section. We would take what we were trying to prove, we would make it the last statement in our notes, and we would try to come up with a reason for that. And then the entire proof will be trying to make that reason happen and justify all of that. So then we think, what's all the ways that we could prove that two angles are equal? Well, we got to go back into our minds. And so we go through and we start thinking, okay, we had undefined terms, point, line, plane. We had a segment. We had the definition of a ray, the definition of opposite rays, definition of a midpoint. That gives us two equal segments. Definition of an angle bisector. That gives us two equal angles. Definition of perpendicular, equal adjacent 90-degree angles. So we got angle bisector gives us equal angles. We've got perpendicular lines give us equal adjacent angles. We got vertical angles are equal. So there's another one. Vertical angles are equal. We've got addition, property of equality, subtraction, property of equality. Remember all those? Addition, subtraction, multiplication, division, substitution, transitive property. And then we have what we learned today, supplements of equal angles are equal, and complements of equal angles are equal. And so we're thinking, okay, vertical angles are equal, perpendicular lines, complements of equal angles are equal, supplements of equal angles are equal, addition, subtraction, multiplication, division, substitution, transitive. We got all that in our mind, and so we're going to look at the given, and we're going to look at the diagram, and we're going to look at what we have in the notes section, and we're going to see what it looks like we have in the way of one of those things we just listed. So let's just start talking about stuff. Well, vertical angles, they're angles across from each other. These are definitely not. So vertical angles is out. We're trashing that one. Perpendicular lines are two lines that form equal, adjacent, 90-degree angles. These angles right here are not, if you look at the picture, a part of something perpendicular. So we trash that idea. Substitution says if two things are equal, you can put one in place of the other. Well, substitution, we're not going to throw that out yet. Addition, you can probably look in here and see that if we want to get that whole big angle, we could add these pieces up, right? This angle plus that angle is that whole big angle. That would be angle addition. So there could be some addition going on. There might be a little substituting going on. But if you're familiar with what we just got through doing, you may go, oh, look, we've got a straight angle. And a straight angle is 180. And that means that this angle over here, this little one, and that big one are supplementary. And it's a straight line this way too on the bottom. And so that's a linear pair. And so those are supplementary, this little one and that big one. And we know that this angle is equal to this angle. So we have supplements of equal angles. And so it seems like we're going to use the theorem we just learned, supplements of equal angles are equal. And so, again, let's kind of erase some of this stuff up here because it's probably getting just a little bit busy looking. And review this again. I'm saying going through the same thing several times here just because I realize that we're trying to memorize a process, see? And so we're going to write the given, proof, put the statements on the left, reasons on the right, draw the diagram. That's just setting it up. We took what we were given. We marked it on the diagram. What we get out of it is two equal angles, and we write statements and reasons derived from the markings in the notes section. We'll take what we're trying to prove. and we make it the last statement in the proof because it's kind of like a road map. This whole proof is telling us how to get right there. Well, when we get where we're going, we're done. So that's the last step of the proof. We're trying to think of every possible way to prove that two angles are equal. We said, well, vertical, they're not vertical. Perpendicular, we don't see anything 90. And we just looked at it until we realized that we have a straight angle and linear pairs, so we have supplementary angles, and we have supplements of equal angles because those two green angles marked in the picture are equal. And so we say, I'm going to prove this by supplements of equal angles are equal. So then we say, well, if I'm going to prove that they're equal because they're supplements of equal angles, then I need a statement that says that the angle that ABD is a supplement of is equal to the angle that EBD is a supplement of. So I need to know, I need a statement that says that ABD is a supplement of something and EBD is a supplement of something, and that those somethings that they're supplements of are equal before I can say supplements of equal angles are equal. So here's the statement. See, ABD is a supplement of ABF. ABD is a supplement of ABF. I need a statement that says they're supplements. And this angle, EBD, is a supplement of this angle, EBF. If I'm going to say supplements of equal angles are equal, I need a statement saying that these two angles are supplements of so-and-so angles. But I got to have a reason for that. I can't say it. Now, I'm not trying to prove this anymore. Exactly. See, I already know that the angles I'm saying those are supplements of are equal. I've got that over here in my reasons in my notes section. See, that came from an angle bisector. So I see that I have supplements of equal angles, you see. But I need to be able to say that ABD is a supplement of ABF. And I need to see that EBD is a supplement of EBF. And so I have to say, well, how can I say something supplementary? Well, the only way I know to say that something is supplementary is by the definition of supplementary. Well, what is the definition of supplementary? Well, we're going to make that our reason. Well, supplementary angles are two angles whose measures have the sum of 90. I need to be able to say that these are supplements to be able to reach that conclusion. But before I can say they're supplements, I have to have a statement that says that the sum of their measures is 180. And then here's the what you get out of it. And here's the word. And once you have the word and what you get out of it, you can say definition of. So I can say definition of as long as I can prove that. So now my job is no longer to prove this or prove this or prove this. My job is now to prove this. Well, how can I prove that those add up to 180? Well, it didn't come from the given. If we look in the diagram, we see that, hey, those two angles go together to make a straight angle, and a straight angle is 180 degrees. So I could say that they add up to 180 because of the definition of a straight angle Or maybe definition of a linear pair, although I prefer that it say linear pair first, but some texts might allow you to say definition of a linear pair. And we have taken a little bit of liberty because it could be that someone would want to say that this angle plus this angle is equal to the whole big angle, and the whole big angle is 180 by definition of a straight angle. And so the sum of those 180 by substitution. So there is the possibility of the statement that angle ABF plus angle ABD is equal to the whole big angle, angle FBD, and that would be angle addition. And then we could say angle FBD is a straight angle by definition of straight angle. I'm sorry, angle FBD is equal to 180 degrees by the definition of a straight angle. And then we could put that 180 in place of angle FBD, and that would make, forget I did that. That would make this substitution that got messy. I may have confused you in that. So let me clean that up, talk about that just a little bit again. So what I said is I'm okay if you look in that picture and say that this angle plus this angle is 180 and call that definition of a straight angle. Technically, that's fudging just a little bit. What we really should say is that this whole angle, angle FBD, is equal to 180 degrees by the definition of a straight angle. And then we can say that this little angle plus this big angle, angle FBA plus angle ABD, is equal to the whole big angle, angle FBD, by angle addition. And then we could put the 180 in place of angle FBD and get that angle FBA plus angle ABD is equal to 180 by substitution. So we called this definition of a straight angle, taking some liberties not to show all of that work right there. You may have an instructor that says, hey, I want you to show all of that. We're not going to take those liberties, you see. Okay? Now, we needed this statement right here to connect with this statement so that we could make this conclusion. Because we made the reason supplements of equal angles are equal. Well, the angles that these are supplements of are these two. And so there has to be a statement up here that says that those two angles are equal. Or we can't reach that last conclusion. See, that last reason still needed that statement. And we can justify that statement with the reason definition of an angle bisector, which we've already taken care of in our note section over there. But before we can say definition of, we need the word and what we get out of it. So we have to have this word, and the reason is given. Well, all of a sudden, everything's filled in. It looks like we're done because there's no blanks to fill in. And so let's act like we were doing this proof all by ourselves again. The last thing that it says to do is to check the reasons from the bottom up. And I'm going to get all the things out of the way that are extra. Okay, so what we want to do is check the statements and reasons from the bottom up. This is going to verify that our proof is exactly like we want it and it's all in the right order. I'll finish cleaning this up just a little bit. Okay, so final reason, supplements of equal angles are equal. Well, these are the angles in question. So I need to be able to find those angles being supplements of some other angles. Okay? Well, here I have those two angles, ABD and EBD, being called supplements of other angles. And I need a statement that says that those two angles that they are supplements of are equal to each other. So this reason is justified because I can see in the proof everything that it says, and I have to have this statement and this statement and this statement to say it. That means that I need those three statements. I can't throw any of them away. So we're trying to say, do I need everything I've got? Is it in the right order? Or do I need some more stuff? We got to have all of that to say that last reason. So what we're going to do is go to the next needed statement. So this is kind of checked off, that whole line, you see. So we go to the next needed statement, and it says ABD is a supplement. And so we look at the reason, definition of supplementary. Well, to say definition of, we need the word supplementary and what we get out of it. Well, here's the word, so we need that statement. And what we get out of supplementary is that the sum is 180, and so I need this statement and this statement to be able to make the reason definition of supplementary. So this reason is justified in these two statements. So I go to the next needed statement, which is this one. And I look at its reason, and its reason is definition of, and I have to make sure that's justified. Before I can say definition of, I generally need the word and what I get out of it, unless what we are using is something we can see visually from the diagram. If it's something we can see visually from the diagram, we don't have to have the word and what we get out of it. We do not have to have the word and what we get out of it. So the what we get out of it, we see in the picture. And then we have the word straight angle. And so we're going to say, I need this statement, and I use the picture to make that reason, so that reason's justified in the statement that it adds up to 180, and in the picture where we can see it's 180. We go to the next needed statement, which is this one. And we look at its reason, which is definition of, and we know to say definition of, you have to have the word and what you get out of it. So here's the word. That means this statement is needed. Here's what we get out of it. So these two statements are needed to make that reason, so that reason is justified. We go to the next needed statement. The next needed statement is this one. its reason is given, and we don't need any more statements to say given, and so that reason is justified. It needs no more statements. All of a sudden, we realize that every single statement is needed, every single reason is justified, so we must have done our proof correctly. Any questions on that? Okay. All right. That may have seemed complex, but I hope with all of the explanation and all the color splashes everywhere that we helped you instead of hindered you. It's going to take a few run-throughs, obviously, before you get good at proofs on your own. So let's look at the next proof. What we're going to do here is we're just going to white out all of this. And we're going to do the entire proof from scratch. Okay. Now, it could have had a statement, given that AC is perpendicular to EB and angle ABE is equal to angle CBF, prove that angle DBE is equal to angle FBE. And that's all it could have given us. And if it gave us that in a sentence or paragraph, then we would have set up the chart like this. We would have written the given, and then the prove, and then we'd have done a proof. I have students that say, well, what do you put for proof? Well, the proof is the statements and reasons, you see. The statements and reasons are the proof. So you don't put anything beside proof. The statements and reasons are the proof. Okay? All right, we wanted to make sure we cleared that up. That's something that pops up all the time. Okay, so we've written the given proof, put the statements on the left, reasons on the right, drawn the diagram. Now what we're going to do is take what we're given, mark it in the diagram, and write statements and reasons derived from the markings in the notes section. That means we need a notes section. So this first given statement says that AC is perpendicular to EB. Now we've got to know our definitions, postulates, and theorems, as we've said before. AC is perpendicular to EB. We know that perpendicular lines are two lines that intersect to form equal adjacent 90-degree angles. So what do we get out of that? We get out of that equal adjacent 90-degree angles. So we can reach the conclusion that angle ABE is equal to angle CBE by definition of perpendicular. Now, if I'm going to say definition of, then I need the word and what you get out of it. The fact that they're equals to what I get out of it, so that means I need the word also. So I have to have this in the proof before I can say definition of. I've got the word and what we get out of it now. We could also say that angle ABE is equal to 90 degrees with the same reason, definition of perpendicular. We could say that angle CBE is equal to 90 degrees by the same reason, definition of perpendicular. And that's about all we can conclude out of that given statement. There's stuff out of the picture we can conclude, but not from that given statement. So we go to the next given statement, and it says that angle ABD, that's this little guy right here, is equal to angle CBF. That's this little guy over here. And we're going to mark that in the diagram, and we're going to write that in our note section. Angle ABD is equal to angle CBF, reason given. You can analyze that a little bit, and you can start seeing something we've studied in this same lesson at the very beginning. But we're going to just kind of put that thought on hold for just a minute so that we can really follow the flow of the proof method that I'm teaching you. So here's what we've done. We've written the given proof, put the statements on the left, reasons on the right, drew the diagram. We take what we were given, we marked it on the diagram, and we wrote statements and reasons derived from the markings in the note section. So we have our proof partially done. Now what we're going to do is we're going to take what we're trying to prove, and we're going to make it the very last statement in our proof. Angle DBE is equal to angle FBE, and we need a reason for that. So we've got to think about everything that we've ever learned that has the conclusion that two angles are equal. And we could start listing those things, but we understand that we're eventually going to use the given and the diagram and this note section to try to figure out how to prove the proof part. We're looking for this final reason right here. Now, in case it didn't hit us, then we're going to brainstorm. We start going through the book. Undefined terms, point, line, plane, segment, ray, opposite rays, angle, angle bisector, angle bisector. That gives us two equal angles. Perpendicular lines equal adjacent 90-degree angles. Vertical angles are equal. Angle bisector looks like that. Perpendicular lines look like a T. Equal adjacent 90-degree angles. Vertical angles, angles opposite each other when two lines intersect. All those properties of equality, addition, subtraction, multiplication, division, transitive, symmetric, substitution. Keep skimming through the book, and we go through and we go, okay, we learned today complements of equal angles are equal and supplements of equal angles are equal. So we start looking at the angles we're talking about. We'll just make them green. Angle DB, it's this one. And angle FBE, that's this one. We say, okay. Angle bisector, ooh, that looks kind of like that. Now, to do it by angle bisector, we would have to know that ray BE bisects angle DBF. Now, we don't know that one. We knew it bisected the straight angle. We knew it was perpendicular, but we don't have anything about an angle bisector, but that's some rare possibility. Perpendicular, it's definitely not perpendicular lines, what we're seeing in that green stuff there. We're not seeing perpendicular lines. We're not seeing vertical angles. We can trash that. We could twist it up with some addition, subtraction, multiplication, division, maybe. Getting an angle bisector out of that, we'd have to have the word and what we get out of it. We're trying to prove that what we get out of it, so we would have to have the word. We don't have the word. We're going to have to get the what we get out of it some other way, so that's obviously not it. So that's out. Looking at the picture, we know again that this angle is equal to this one. This angle right here is equal to this angle right here. And we know that those green angles were equal. And we can see that this green and black on the left add up to 90, and the green and black on the right add up to 90. And if they add up to 90, they're complementary. And the black one is equal to the black one. So the green ones are complements of equal angles. And so we go, it's that one. It's that thing we just learned. Complements of equal angles are equal. So we went through the ways that we could prove it, and we used our given and diagram and said it can't be this, and it can't be this, and it can't be that. But it sure looks a whole lot like this one. And so we must be going to prove it by complements of equal angles are equal. Now, that didn't look too good over there. That black I just smudged in, but that's what it says. I'm kind of to the edge of the board there. Okay, complements of equal angles are equal. So then we think, well, if I'm going to prove that these two angles are equal because they're complements of equal angles, I needed a statement saying what these are complements of. So I need a statement that says angle DBE, angle DBE is a complement of something, and angle FBE is a complement of something, and I'm going to have to know that those two somethings are equal. Now, what are those two somethings? We're talking about the green ones, and so this black one, angle DBA, is the complement of the green one, DBE, and this black one, CBF, is the complement of the other green one, EBF. And so we see that these two angles are complements of two other angles. But if we're going to say that they're complements of other angles, we have to have a reason for that. Now, the only reason we can say something is complementary is by definition of complementary. So the reason for that has to be definition of complementary angles. And if the reason is definition of complementary, then to be able to say definition of complementary, we have to have the word complementary, which is there, and the what we get out of it. And what we get out of it is that they add up to 90. So we would need a statement that says that angle DBE plus angle DBA is equal to 90 degrees. And a statement that says that angle FBE plus angle CBF is 90 degrees, but we need a reason for that. Well, we can look in the picture and see that they add up to 90, but that's not like the definition of a straight angle, which connects to a linear pair. We're going to have to do that substitution thing that I showed you all ago, because we can't just say linear pair thing or straight angle thing. We know that this whole big angle ABE is 90 by the definition of perpendicular. There's that statement. And we know that this whole big angle, angle EBC, is 90, also by the definition of perpendicular. There's that statement. But somehow we need to get from angle ABE to these two. But we know that these two add up to angle ABE. We can see that in the picture, and what that is angle addition. So we're going to say that angle DBE plus angle DBA is equal to the whole big angle, angle ABE, and we're going to say that this other angle, angle FBE, plus the other little angle on the other side, we're dealing with this side now, angle CBF, is equal to this whole big angle over here, angle EBC. And both of those have the same reason, angle addition. Angle addition. Well, how am I going to bridge the gap from here to here? Well, this says that big one is 90. This says the sum of the two little ones is 90. This one says that the sum of the two little ones is equal to the big one. That means I can put the sum of the two little ones in place of the big one. When we replace the big one with the sum of the two little ones, that's substitution. Now, all of a sudden, I'm not saying I need another reason. I need a statement to say that, and to say that, I need a reason, but all of a sudden, we don't seem to need another statement, and we don't seem to need another reason. And so it seems as if we've proven it. And a lot of students will get here and say, you know, I really don't know if I proved it or not. How can you tell when you're done? That's the biggest question of all. How do I know when I'm done? Well, that's the checking the statements and reasons from the bottom up. And so we're going to go through this. Before we can say complements of equal angles are equal, we have to have the two angles in question. We have to see that those two angles in question are complements of two other angles, and that those two angles are equal. So to say complements of equal angles are equal, I need it given that the two angles are complements of are equal. That means I need this statement. I need something saying they're complements of the two angles that we're saying are equal. And then I can say that they themselves are equal with the reason complements of equal angles are equal. And so that final reason is justified. So I go to the next needed statement. This one. It has the reason definition of complementary. Now, if I'm going to say definition of, I have to have the word and what you get out of it. And what you get out of complementary is they add up to 90. And so I need the statement that says their sum is 90 along with the word complementary so that I can say definition of, so that reason definition of is justified in the statements above it. So I go to the next needed statement, which was this one. And I look at its reason, and the reason is substitution. Before I can substitute, I have to have some things that are equal. So I need to see this somewhere and this somewhere so that I can have substituted. Now the 90 is all the way up here. And the little angle equal the big angle is here. And so we're putting the sum of the little ones in place of the big one and getting that the sum of the little ones is 90 by substitution. So to say substitution, I need this statement. I need the statement that gives me the 90. And I need the statement that says that the little ones are equal to the big ones. So I need all of those black statements to be able to say the reason substitution. We kind of did a double thing. Well, I go to the next needed statement, which is this one. And it says angle addition. And it's in the picture. I see it up here in the picture, so that's justified automatically because the picture gives it to me. And substitution got justified. And this statement is also angle addition, which is justified in the picture. The next needed statement is this one, that these two angles are equal, and that was given, so given is justified with no further need of more statements. See if it's in the diagram, like angle addition or definition of a straight angle, or if it's given, there's no more statements required. That's how we dead end. We start getting some of those that don't require another statement. The next needed statement was definition of perpendicular. It was these two statements which both had the reason definition of perpendicular, and actually that one. So to make those three statements with the reason definition of perpendicular, we have the what we get out of it, what we get out of it, what we get out of it, but we needed the word. So we need that statement before we can make any of these three reasons. Definition of, we have it, so that's justified, that's justified, that's justified. My last needed statement is this one. The reason is given, which is justified. It requires no further statement. So we know that we need every single statement in the order that we have them written, and every single reason is justified, so we must have done it correctly. Any questions on that? So now what we would do is we would just transfer all of the things from the notes section over to our statements and reasons. Okay? And then voila, there it is. Okay? We'll let you look at that for just a second. It might have been a little bit sloppy over there when we got through, maybe just a little bit. So there's a little bit better view of what our final proof looked like. Okay? All right. So we have a couple of three proofs here for you to try on your own. We're just going to let you practice with those on your own. You really need that practice, and if you get stuck, you really need to get with your instructor and let them try to help you through it. The teacher's edition does have all the solutions. The odd ones are at the end of the chapter, so number 3, you could actually see it